Hello, this is Dr. Liu. In this video, I want to give you an introduction to the speed of sound experiment. So right here behind me is the sound tube, and I also have a number of tuning forks. So the purpose is to find out the wavelengths of each of these frequencies when struck. So we can use the wavelengths and we can calculate the speed of sound. So here let's start with the longest tuning fork. This one says 426.7. Believe it or not, it says A. I know that most instruments are tuned to 440 hertz or A4. But anyway, this is your 426.78. And you want to turn this vertically so that when it vibrates up and down, pushes the air into the column and pull it up, right? So you want to go ahead and secure this thing right above the uh, the glass tube, and I want to turn this to its side a little bit so the vibrating tips are right above this tube. And I have a mallet, which is just a little rubber stopper with a metal rod. So I want to just strike that with a mallet gently to produce a sound. Don't really know how much it can come across my microphone. Well, it's not very loud because we don't really have resonance yet. Over here we have a popsicle stick. This is because we want to hold a string that is holding a movable end stop right here. The end stop effectively changes the sound, the air column of the sound. And below the air stop, nothing's vibrating. Above the air stop, things can vibrate. So let's lower it back down. And now I will pull the string up by just turning. Because of the popsicle stick is flat, we can actually kind of keep it from just unrolling the string. So I'm just getting this thing up here. Make sure I pull up the string evenly so that the end of the string doesn't go to like the extreme side of the rubber stopper. Okay, so I have um, I don't know, 20 centimeters, something close to that, right? Okay, so what I need to do next is to actually to vary the length or vary the location of this rubber stopper in order to hear a loud audible sound, and that will be resonance. So where exactly does it happen? I don't know. We have to find out. Actually, I do know some of these locations. Let's just keep the popsicle stick in place. Hopefully it'll not turn. And grab a few of these well, what do you call these? Probably those stickers for signature, for instance, or it could be uh, used on books, right? As bookmarks. So you can place that onto the tube where you can hear the sound. Let's just say the top of the rod, the movable stop, right? So I'm pretending, but I'm actually going to find this location. Um, I'll take a quick peek at my data from the past. So this two 426 hertz, uh, close to 20 centimeters. So let's grab a meter stick and see where the 20 centimeter is going to be. So that will be measuring from the top or the opening all the way down. Yeah, we're about 10, 12. So 20 is close to this point. So all I have to do is to scroll this up, and I can lower the stopper a little bit at a time, and try to have a listen to to tell when the sound is loudest. And that is when I stop and place this bookmark or signature indicator at the top of the stop, movable stop. So I'll try to do that now. Don't really know how much you can hear this. You may have to keep striking the tuning fork. Here's a spot where the resonance is high, so you can hear the sound a bit louder. And the way to confirm is try to pull up and lower down around this position, so you can hear this kind of ringing sound. That tells you that you're at approximately the right location, and then you can determine the position by making adjustments and also try to tell how much of an uncertainty you would have, such as is that a millimeter uncertainty where the maximum loudness is, or maybe a centimeter, right? So let me try this again. Oops, I just happened to hit that. No, my popsicle stick is hitting the uh, tuning fork. I think it's roughly here. Yeah, it's roughly here. So I'll place a mark. So the top of the mark is lined up with the top of the this thing here. All right. So next thing is I'll lower this further down, and there will be further resonance where the sound will become loud again. So I'll take another sticker, just place it on the tube, and get ready for the next location. You can do this as a group of 2 students. It's a lot easier than what I'm doing here as a solo experimenter. And also, if you are careful enough, you can carefully carry this into the hallway because there will be 10 groups striking similar sounds, and it'll be difficult for you to discern whether that was yours or someone else nearby. So, if you're careful enough, take the tube into the hallway and make sure that you're not blocking traffic, then you can have a better environment for your experiment. So let me just lower this down a little bit so that I have enough distance to pull up and lower down to tell if there's actually a resonance. So I have enough of the distance. Okay, so I think I might have enough distance now. So let me just pull this up and start striking and have my ear closed and start lowering this stop. I don't think I could have anything here. Maybe it is a little further below, so I'll unwind the string a bit more. This is the lowest frequency, that means the longest wavelength anyway. So I'll try this one more time. I think this is the spot, somewhere over here. So I'll try some more accurate measurements, just striking one more time around here. I think my accuracy may be a little better than a centimeter, but maybe uh, up to 5 millimeters. And the other experimenter will be much better off marking the position because I'm not really looking at it straight on. So I might have some errors due to that. So I'll just mark this right here and hopefully it doesn't fall off. But it does look like it has a tendency to fall off. And from the yellow to the magenta, this is a half wavelength. So I'll expect the next one to be the same distance away. So that means I'm going to unwind this whole thing. See if I can reach the bottom. From my experience, I should be able to get one more location. All right, so now let's see. Maybe I can with this frequency. 1, 2, 3. Yeah, I can, but it's very close to a full meter. Hopefully, no one broke the string enough to make it impossible to reach a meter below. So let me make that a little tighter. So I'll put another one somewhere here, which I'll adjust. So I'll do the same thing, strike, and I'll pull the stopper up and try to lower it to see if that's a ringing. Not enough. Here it is. I'll check it one more time. Yeah, this is a spot. Okay, so there we go. Now we have 3 marks, and I should be able to determine the wavelength. I'll do that in my calculations, but for now, let's see, 3 marks. I'll just focus on getting the positions measured. So I'll take my meter stick, line up the top with the top of the tube, and go for the top of all these bookmarks or signature indicators. I have 19.2. This is another instance where I really need a lab partner, and I have a 60.1, and I have a 97.9. Let's reread the lost value. Start forgetting, is that 19.9 or 90.1? Okay. 90, okay. Sorry, 98.1. 98.1. Okay. Okay, I just wrote down my numbers. You should be able to do that on your computer, but my screen is currently just recording. Okay, so this is for one particular frequency, the lowest frequency, which means the longest wavelength. And this tube is barely enough to do 3 markings. And once you go to a lower wavelength, a higher frequency, 480, you should be able to get at least 3 marks, if not 4. Let me look at my data. Yeah, 3 marks. Until the 512 hertz, you'll be able to get fit 4 marks onto this because the wavelength starts to get less and less. And then you go for the highest frequency, which is 1,000 hertz. And you'll be able to get 1, 2, 3, 4, 5, 6, 7 locations. The last one being slightly beyond the 1 meter range. So you would be better off with a 2 meter stick with that. So that is basically 3 marks for the first and the second, um, the lowest frequency tuning forks, and 4 marks for the 512, and 1, 2, 3, 4, 5, 6, 7. Yeah, 7 marks. I'm okay if you get 6 for 1,000 hertz. And that's everything for this lab. It takes some time and efforts to hear those resonance. They will sound like as you vary the height of that stopper. So that's your cue. If you can't really hear well enough inside this lab room, go to the hallway. Just careful. Be careful with the tube. It's glass. All right. Thank you.